Well, we need some good news right about now, and I feel like one thing I can give you that's good news is that we have reached our final lesson on trig for the semester. Trig dominated, right? For 2/3 of the semester we've been working on trig. This is the last one, which means we're coming up on our final test this week on trig, and then we will turn the corner and we will go back to some algebra and finish our last few units for the year. So congratulations on making it this far. So the last thing I have to talk with you about regarding trig is how to work with distributing. So I want to give you an example question of a problem like this. Sine of A plus B. Now, a lot of students are tempted when they see that, because we've been working with FOIL, we've been working with distributing in other questions, and they want to distribute this. But that is not the rule for trig. You can FOIL when you've got this kind of problem. Let me show you. Let's see. Sine A plus sine B times sine A plus sine B. Like, you can FOIL that because everything has its own sign, and so I can do first, outside, inside, last, and I can totally do FOIL. But that's because all the A's and the B's have their own sign already. In the first problem, the original problem, we cannot FOIL that. Distribute that, because sine is just a word. You can't distribute a whole, just that phrase. So let me show you the right way to do that. So if you have sine of A plus B, the identity or the rule for how that works, what it's equal to, what you would replace that with, is actually four things, kind of similar to FOIL in this order. It's a sine followed by a cosine, and a cosine followed by a sine. So it's sort of like first, outside, inside, last, but not quite. It's sine, the order is sine, cosine, and then another cosine followed by sine, so then it reverses itself. And then what happens is the A goes here and the B goes next. And then A again and B. But notice that the trig words reversed each other. And between those is a plus sign. So you've got like a first section and a second section. These are multiplied, but then between them is a plus. Sometimes people refer to this as the cheer. And if we were in class, I have pom-poms, and you would see me, I have a whole routine done for this, but we chant out sine, cosine, cosine, sine. It just helps us kind of remember the order that it goes by learning the rhythm. So if you hear me refer to it as the cheer, it's because that's what I normally would have done, and I know that you're really super sad to have missed out on seeing that. And no, I am not going to record a video of myself doing that for you. Just have to miss out. One of the great tragedies of our quarantine here because of COVID. But let me show you the rest of it. There is one for subtraction as well. So if we have sine of A minus B, it's not distributing, but it is sine, cosine, cosine, sine again, and the A and the B and the A and the B, but just between them is a subtraction. So we've got a first section, we have a second section, and between it is subtraction. So those are the rules. It's not distributing, it's its own separate identity rule. Okay, the fancy name for this is the trig identity for a sum and the trig identity for a difference. But this is how we're going to work that out. Now there is one for cosine as well. So if you have cosine of A plus B, and how does that one go? Well, this one starts with cosine, but it's a double cosine followed by a double sine. So the rhythm is a little bit different. But the A and then the B and then the A and then the B. Between them goes something maybe you wouldn't expect. It is not an addition, it is a subtraction. And so when we cheer this or chant this out, the rhythm of this goes cosine, cosine, sine, and we spell it, it sounds the same, okay, but we spell it with S-I-G-N, and then sine, sine. So it goes like this, cosine, cosine, sine, sine, sine. The first emphasis on the S-I-G-N is to help us remember that there is a sign change from plus to minus. And so if you're thinking about the rhythm of that, again, it goes cosine, cosine, sine, sine, sine. That's the rhythm. So the overall cheer goes like this. So I'll kind of mark it out as I say it. This is just helps you remember. It's just a memory trick. So we have sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. That's the rhythm. You practice saying it a couple times to yourself, clap it out, chant it out, whatever. But that is how the memory trick for remembering how to deal with not distributing. So then what does it look like if it's subtraction? If it's subtraction, we still have a double cosine at the front. We still have a double sine at the back. The A comes before the B and the A comes before the B, but we have a plus in between to show the sign change. Okay, so this overall is what we commonly call the trig cheer, but it is the sum and the difference formulas for the trig identities. So how does this relate to problems that we would have? All right, so let me give you something to simplify. So suppose you have the sign of x plus pi fourths. Okay, what you don't do is you do not distribute and tell me that the answer then is sine x plus sine pi fourths. That is not how things go. Okay, that would be the wrong way to do it. The correct way would be to go sine, cosine, cosine, sine. You chant your rhythm out. Fill in the x and the pi fourths, the x and the pi fourths. This is a multiply between each of these and an addition. Now you reference back to your unit circle. Cosine pi fourths is on the unit circle. So if we quick in our memory envision what the unit circle looks like, pi fourths is right here. And so the sine of pi x is multiplied by the cosine at pi fourths. So we remember that pi fourths is rad 2 over 2 followed by rad 2 over 2. And so the cosine value is the x value, so we have rad 2 over 2 plus cosine x, and then again, back to the unit circle, that is rad 2 over 2. Now we notice that we got rad 2 over 2 twice. That is called a common factor. So we'll pull the common factor out to the front, rad 2 over 2 in front of, and then we are left with sine x plus cos x. Now some people are tempted to want to replace sine x plus cos x with 1, but that is not true. If these had a square, then I would say for sure, go for it. That is the Pythagorean identity, and then you can replace it with 1. But without the squares, if it's just sine x plus cos x, you can't replace it with 1, and that's just the final answer. Rad 2 over 2 on the outside, sine x plus cos x on the inside. And that is it. That is the final version of your answer. So instead of distributing, you did the cheer. Let's try another one. Let's do a cosine one this time. Okay, so let's try cosine of x minus pi thirds. Okay, we don't distribute, we do the cheer. The cheer for cosine is a double cosine followed by a double sine So this is cosine, cosine, sine, sine, sine. We fill in the x, we fill in the pi thirds. By the way, you only ever fill in positive things. Okay, never a negative, always a positive. So x and pi thirds. What goes between them is a multiplication and another multiplication, and then in the center, we change it to an SIGN. This is the only one that changes sign. That's because it's cosine. The cosine rule has the sign change in the center. We go back to our unit circle, and we want to look at pi thirds this time. So we want to reference what cos pi thirds and sine pi thirds are. So we think about our unit circle. We remember that pi thirds is about right here, and pi thirds is 1/2 rad 3/2. So we've got our cosine and our sine value. So this would be cosine of x times the cosine value, which is 1/2, plus sine over x times the sine value, which is rad 3/2. Now nothing is in common here. Not like last time. Last time we were able to factor out. This time we can't. So we write our answer this way. 1/2 goes in front of cos x, and rad 3/2 goes in front of sine x, and that is the final answer. Here's another example. Let's try the cosine of pi halves plus x. So here's another cosine. We don't distribute, we do the cheer. Cosine, cosine, sine, sine, sine. Notice I changed the sign of the addition to a subtraction. I fill in pi over 2, I fill in x with the times in between. I fill in pi over 2, and I fill in an x with the times in between. So I'll think about my unit circle. I want pi halves, which is straight up on the unit circle. The value there is 0, 1. 0 is for cosine. And so we have cosine of pi halves right here is 0 times cosine x minus. And then sine pi halves, that is 1. So 1 times sine of x. So 0 times cosine of x wipes it out. And so I have negative sine of x, which is my final version of this answer. Okay, let's look at what happens in this case. So what if we have cosine of x plus y minus cosine of x minus y? This one doesn't have any unit circle on it at all. But that doesn't stop us. We don't distribute, but we're going to do the cheer. And so my cheer is cosine, cosine, sine, sine, sine. All right, that is this one. Cosine, cosine, sine, sine, sine. Then I also have the cheer for this one. Cosine, cosine, sine, S-I-G-N change, sine, sine. All right, and then I fill in a positive x, positive y, positive x, positive y. Then there's this minus sign here, so minus all of this. Fill in a positive x, a positive y, a positive x, a positive y. The only thing that gets distributed is this subtraction. There we go. Okay, that subtraction is the only thing that actually gets distributed in this problem. So overall, we are left with cosine x times cosine y minus sine x times sine y minus cosine x times cosine y minus sine x times sine y. So the only distributing was that little bit. Now we look at what we've got. Do we have anything that's in common? We should notice that I've got cosine x times cosine y and another cosine x times cosine y. One's positive, one's negative, so they cancel each other out. I also have a negative sine x sine y and a second negative sine x sine y. So together, those make negative 2 sine x sine y. And that's the final answer for this version as well. Okay, last couple. Go back to the unit circle a little bit here. What if we have sine pi fourths times cosine pi twelfths plus cosine pi fourths times sine pi twelfths? Okay, now you got to run this whole thing backwards. Where did this come from? If you recognize the order, this is sine, cosine, cosine, sine. That means it came from something that had a sign on the outside. It did not have a sign change, S-I-G-N. But the order of the rhythm, sine, cosine, cosine, sine, means it came from what would have been a sign. And the A was positive pi fourths, and the B was positive pi twelfths. So we want to keep going backwards for this. We need a common denominator between these two. And the only way for that to happen is for me to multiply this by 3 and multiply this by 3. I realize that this kind of looks like a y. It's not, it's a 4. Okay, there we go. And so we will have, back up a little bit, sine of 3 pi twelfths plus pi twelfths. We can add those together because they have a common denominator now. This is like a 1. So now we have sine of 4 pi twelfths. Now 4 pi twelfths is reducible. That is the sine of pi thirds. And the sine of pi thirds is a position on our unit circle. And the position of the sine of pi thirds is rad 3 over 2. And so the answer to this overall question is rad 3 over 2. All from being able to work backwards. All right, last one. How about the cosine of 50 degrees and the cosine of 40 degrees minus the sine of 50 degrees there we go, and the sine of 40 degrees. So these are all degrees now. Now how this is going to work? Okay, well, we look at the rhythm, and it's a double cosine followed by a double sine. That means it had to have come from the cosine version. And in cosine, we have to have a sign change. And so the negative in the center turns to a positive. And this would have 50, and this would have 40. Now 50 degrees plus 40 degrees adds up to 90 degrees. And so we want the cosine of 90 degrees. The cosine of 90 degrees is straight up on our unit circle. Since that's the position 0, 1, the cosine of this is 0, which is the x coordinate. So that is the last unit of trig, what we call the cheer. It's really just a way to avoid distributing when you're not supposed to, when you're working with addition and subtraction. All right, good luck with this as you wrap it up, and we will be testing on trig identities overall and on Wednesday of this week.